Thank you. I'm excited to be here today. I'm Doug Hill. I'm the founder of Real Random. We're based in Tampa, Florida, and our mission is to build a safer digital world. Next slide, please. The problem we're solving for is the threat of quantum computing, and that being a threat to national security. And when we think about quantum computing, we want to look at what we have today in von Neumann boxes and modern computing, where process is linear, one input and one output. When we think about quantum computing, we want to think about parallel processing and the computer's ability to process all possible combinations of a cryptographic key simultaneously. Next slide, please. And so when we consider Roger Grimes, who's a author of more than 15 books and well-publicized evangelist of computer security, we want to think about how quantum computing is going to affect us, not just in the positive ways in developing new vaccines, but Q-Day. When is Q-Day? When is the day that quantum computing becomes useful as a weapon for cybercrime and espionage? This is a book I recommend anyone who's interested in quantum computing and computer security that they check it out. Next slide, please. So as a practical example, if we consider a cryptographic key as a maze, if I'm an attacker, I want to identify the seed state where I then can determine a pattern that leads me to successfully decrypting the key. And so if I think about linear processing, I can try only one combination at a time, just as a human takes a pencil and that paper to attempt the key. And we'll move to the next slide. We can see that in parallel processing, you're able to try all combinations at the same time. That's a big problem when we consider public and private key infrastructure that's used today to safeguard our data and protect our network systems. Next slide, please. So the solution is better entropy. Entropy is a measure of the lack of order. If you consider your first day of high school, that was a day that had very high entropy. It was a day when there was a lot of confusion, a lot of chaos. And so when we think about computer security, staying one step ahead of that bear is the idea. We know the bear's coming, and we know that there are options and things we need to prepare, especially with things like quantum computing on the horizon. And so the solution is better entropy from physical non-algorithmic sources to use as seed values for cryptographic algorithms. The plot on the left is from atmospheric noise, and you can see clearly that there's no detectable pattern, versus on the right, that this is classic pseudo-random number generator, or you're using a mathematical formula to take some value that's been derived from the computer network itself. Next slide, please. So there's been some improvements in non-algorithmic entropy. On the left, we can see that Intel's classic mathematical entropy, where data is collected, random data points, and used to seed cryptographic algorithms to generate keys. The problem is that anything that's engineered can be reverse engineered. And so it's deterministic and can be predictable. And that is how those keys that are securing our network can be cracked. And so in the center, we have Cloudflare, a leading content delivery company that's using centralized biomechanical entropy, actually 100 lava lamps on the wall of their headquarters. And they stream video and hash that video to get the randomness out of the video and use it to seed their cryptographic systems, so that they have a completely unpredictable source of random numbers, but it's not scalable for data centers. So what we've developed is that same approach of physical non-algorithmic entropy in a reliably unpredictable design for data centers. And so a rack-mount system where you can have the devices installed for on-premise generation of entropy in order to seed your cryptographic systems. Next slide, please. What makes us unique is that Our process is visually verifiable. You can look at the device and understand that the device is acting in a way that's intended, engineered to act. And you can see that it's truly a random output, much like shaking a snow globe, except that we've configured it to slide into server racks to be an appliance for a consistently reliable source of unpredictable true random numbers. And it's not subject to supply chain attack. And that's a really important point. If I have a Geiger counter, which is commonly used, or other sources of entropy using atmospheric noise, we can't see radioactive decay as a human. And so in our device, you can look at the device and, again, understand that it's doing what it's supposed to do and have that confidence that you're not producing random values just from copper and plastic on a chip. Next slide, please. So this is the physical proof. This is our only statement. This is our ability to show our customer how the random number was generated. And the customer owns this. When you generate a key today from, let's say, a service, it's generated typically from an algorithm and you trust it. In our case, you can see it and believe it. And so this is an excerpt from our user interface that manages our hardware. And it's important because it's the root entropy. You actually own that source of the random number. The next slide, please. So we now have a TRL-6 commercial hardware prototype as of July of this year. We have utility patents filed for secure end-to-end communication for things like protecting UAVs and really any IoT connected device. We're working with Softworks at Tampa, Florida-based innovation lab for the US military in order to develop type 1 in-field encryption for the warfighter, where they will be able to provision in real time unique one-time passcodes for their hardware. And they will have the assurance of knowing that the device is operating in the way that it's intended to operate.
30-second warning.
Thank you. So we are seeking opportunities for technical integration programs with defense, banking, and healthcare organizations in order to share our technology and advance the development of the technology to build a safer digital world. Thank you.
Thank you, Doug. Thank you, Doug. We will now be opening the floor up for Q&A. Whoever wants to ask, jump in. Otherwise, Josh, the floor is yours. All right, Han.
Yeah, I'm usually the first one here, right?
Hey,
can you tell us about your business side of it? Do you have any traction or any plan, or could you tell us a little bit more about that? You have great technology, actually. With the quantum computing is the way it goes. Yeah, it is definitely a concern. So thanks.
Thank you. We're just transitioning from being an R&D company for 6 years. It took 7 generations of hardware to get to where we are today, because we weren't able to take something that was pre-existing and improve upon it. There's never been a true random number generator that's hardware-based, that's analog, and uses an electromechanical process. And so really Softworks is our foray into supporting the warfighter. And we are looking to build on that with other similar opportunities, whether it's DefenseWorks or AppWorks, et cetera. So at this point, our traction is Softworks and that opportunity.
Thank you.
Thank you.
Bob, the floor is yours.
Sure. Thank you. So are you creating a new visual language around these random numbers and then this language that becomes a library? I'm just trying to think, how do you extrapolate from there a greater data set that would say, here's similarities in random numbers and sequences and that we're seeing in different attacks? Is there a way to just gain intelligence of pattern recognition through your image, your visual language system?
We are not creating a visual language system. We are creating a resource in the form of an API for seeding things, whether it be for simulations in a SOC or Monte Carlo simulations for banking industry. So we are not creating a language. We're simply creating a source for true random numbers or pure entropy.
I'd like to see your presentation because it doesn't quite. I heard what you said, and I work with quantum computer startups. So I know enough about quantum computing. I know that's not what you're doing, but I also know how some of them operate. I just like to talk more about this in depth offline. So I have some questions about that.
Thank you.
Yep.